Again, number two is in a nice form. It's the form we like for cubics. And what we're going to write down is write down what the A is. The A is minus 12, and the B is going to be 16. Then what do? I plug it into the formula. Again, I'm not expecting anyone to memorize that formula. You write it down. Plug the numbers in, do the arithmetic, and lo and behold, you get a very simple rational root. All right? So someone could say, could I have done that using a rational root theorem? Of course you could have. What's the rational root theorem going to be? You would list the potential roots of this thing, plus or minus 1, 2, 4, let's see, 8, 16. The problem with the rational root theorem is that you got to test them out now. And I don't know what's easier. I mean, doing this arithmetic here or testing those out. Now, again, if I couldn't remember the formula, I would say testing out the rational roots would be the easiest way to go. But you'd eventually arrive on minus 4 as being one of the roots. Then what do? You're going to use that to find the other factors to the problem. Now, I know they did it by long division, but I'm going to do this thing by equating coefficients. So I'm going to say x cubed minus 12x plus 16 is going to factor into x plus 4. Now, the reason x plus 4 is because x minus 4 is a root. That would certainly make that 0. Then it can be a quadratic here. Why x squared? Because x times x squared was x cubed. I don't know the middle term, but the last term I do, it's got to be plus 4. I'm going to equate coefficients now. So I'm going to say minus 12x. And by the way, I'm not being thorough here. I'm just being partial on it. All right? So what do you get over here? What's the linear term going to be? Well, it's going to be 4x plus 4bx. What does this mean? Minus 12 is equal to 4 plus 4b. Whoops. Minus 16 equals 4b, or b is minus 4. Let me get my eraser out. I'll put that down now. Now, what's nice about the remaining problem, it's quadratic. It's pretty easy to solve it. So I'm going to erase my coefficient equating here and solve that quadratic now for its roots. So what's that mean? X squared minus 4x plus 4 equals 0. X equals, that's going to be 4. And by the quadratic form, it's pretty easy to derive and to remember. This guy up here might be tough to remember, I'll be honest with you. But anyway, some people can, they can. What goes on bottom? I'll do the radicand later, by the way. Twice a, which is 2. This is going to be 16 minus 4ac, right? And what do you get over there? Well, 16. So what do you get over there? Something pretty simple. You get x equals 2. By the way, I'm starting to realize that could have been factored. Beautifully so, too. X minus 2, x minus 2. So it was really kind of, and I think I would have gotten out by the rational root theorem much quicker than this technique. But anyway, we're trying to learn a new technique. So what are the roots going to be? The roots are as follows. Minus 4, 2, and 2 occurs twice. It's a repeated root. All right? Let's see if they got those written down. Minus 4, 2, 2. All right, we're good. Thank you. Oh, reminder again. I'm Ron Bannon. I keep doing it. I'm Ron Bannon. My email address is Bannon, B as in boy, @ NNON.US. Thank you.